These are solutions to today's warm-up problems. Number one asks you to explain in your own words what the word derivative means. Big thing is slope. That's if you said something about slope or rate of change. The derivative is the rate at which a function is changing. Number two asks us to use the limit definition of derivative to find the derivative of that guy. Limit definition of derivative says the limit is delta x, or I'm going to use h, approaches 0 of f of x plus h minus f of x all over h. That is the same thing as the derivative of f of x. F of x plus h would be 3 times x plus h squared minus f of x all over h. And continue evaluating. Square x plus h. Distribute your minus sign. Distribute your 3 here. Lots of things should cancel out. Three x squared minus 3x squared, negative 5 plus 5, negative x plus x. Goodness gracious. This should be 2xh. Factor an h out. And plug in 0 for your h, 6x plus 1. And if you remember the power rule, you should be able to verify very quickly that the derivative is 6x plus 1. Numbers 3 through 7. Let's start with number 4 because it's the easiest one to find the derivative here. Remember, you put the 4 out front, so we've got 7 times 4 is 28. Subtract 1 from the exponent. 2 times 3 is 6, x to the first. The slope of 2x is 2, and the slope of a constant is 0. Number 3, we're going to use the power rule by moving that x to the 7th to the top. Negative 7 times 2, subtract 1 from the exponent. Negative 7 minus 1 is x to the negative 8th. Write this one as x to the 1/3. 1/3 minus 1 is negative 2/3. Number 6, divide everything by x squared. So I would get x minus 3 plus 4 over x squared, which is x minus 3 plus 4x to the negative 2nd. And then take the derivative. 1, derivative of a constant is 0. 4 times negative 2 is negative 8. Subtract 1 from the exponent. And number 7, sketch a function that is continuous but not differentiable. Continuous means no holes, no jumps, no vertical asymptotes. Differentiable means that the slope exists. So I need the slope to not exist, but I can't have any holes, jumps, vertical asymptotes. That's when I would have that sharp curve at x equals c.